Hello everyone, it's me Kathy again. Today we are going to review a problem that is useful for college physics and university physics 1. It's a one-dimension problem. So here we have the problem. A car is speeding at 33.4 meters per second. A police car starts in pursuit from rest when the car is 100 meters away from him. At what rate must the police car accelerate to catch the speeder before the state line 1.2 kilometers away from the speeding car? So the first thing that we have to do when solving those problems is a drawing or a diagram. So right here we have our police car, and then 100 meters away we have the speeding car. And then this distance right here is the distance of the speeding car with respect to the line state. So if we read the problem again, we'd see that the speeding car has initial velocity of 33.4 meters per second. And since it's the speeding car, we are going to put a subscript S to identify the velocity. And then right here, we have the velocity of the police officer initial was 0 meters per second. And we also know that the distance between the police officer and the car is 100 meters, and the distance between the car and the state line is 1.2 kilometers, which is the same as 1 to 1200 meters. Okay, after we make our drawing, we identify our variables that are given. We need to identify what we want. So we need the rate at which the police car must accelerate. So we are looking for the acceleration of the police car. Okay, and then right here we have the formulas for one dimension with a constant acceleration. So right here we are assuming that the car keeps its acceleration, which is 0 since it's not speeding up, and we want to find the acceleration of the police car that we don't know. That's what we're looking for. So looking at all these formulas and with the variables that we have, the first one that we're going to use is this one right here. And we are going to use the variables of the speeding car. So we have the delta x of the speeding car is equal to the initial velocity of the speeding car plus 1/2 the acceleration times the time square. We know that the acceleration of the speeding car is 0. It has a constant acceleration. The distance that we have is the distance from the car to the line state, which is 1 to 100 meters. We have to make sure that we had the right units when we are plugging numbers in the equations. We need to make sure that every unit is the same. Since the velocity of the car is in meters per second, it's easier to convert the distance, which is 1.2 kilometers, to meters, which is 1200 meters. So now we substitute the velocity, so it's 34.4 meters per second. And then we have a time that we don't know. We are looking for that time so we can find the acceleration of the speeding car. And we know that the acceleration is 0, and that's multiplied times the time square, the 1/2, so this is gone, this is just 0. Now we solve for the t variable right here. So you have the 1200 meters divided by the 33.4 meters per second, and that's equal to our time. This m on the top with this m on the bottom cancels, leaving us only with the s, and then 1200 divided by the 34.4 meters per second, it's 35.93 seconds. So that's the time that it's going to take for the speeding car to get to the state line. So now we go back and we pick again the same equation, but now we are going to use the variables of the police car. So now we have delta x, which is the distance of the police car, is equal to its initial velocity plus 1/2 its acceleration times t squared. So now the initial velocity of the police car is 0. So we can forget about this term. Now we have to be careful with this delta x. For the speeding car, it was 1200 meters, but the police car is 100 meters away from the speeding car. So that means that we have to add the 1200 meters plus the 100 meters, making 1300 meters. So now we have the 1/2, and then we have the acceleration, which is what we're looking for, and then we have the variable t squared, which is the time that it's going to take the speeding car to run from its point to the line state. So it's 35.93 seconds and square. Again, now we are going to solve for this variable, which is what we're looking for. So we rewrite our equation, and the first variable that we are going to move is the 2 that is dividing the whole equations. And the way we do that is by multiplying everything by a 2, because we know that 2 divided by 2 is just 1. And then after that, we are going to have 2 times 1300 meters times equals to the acceleration times 35.93 seconds square. And then to remove this variable right here, we are going to divide by 35.93 seconds square, and right here too, 35.93 seconds square. And we know that this is just 1. So at the end, we only have the acceleration is equal to the 2 times the 1300 meters divided by the 35.93 seconds square. And if we plug in everything in the calculator, we know that the acceleration, AP, is going to be equal to 2.014 meters per second square. And that's our answer. That's how fast the police officer has to accelerate to catch up the car just right before the line state. So that was the video for one-dimension analysis. And if you need more help in physics, you can come to the lab on Cortex 108. Thank you.